Alright, so when we had this plugged in, we calculated later that the numbers we were seeing, we were getting about 4.675 watts, which is, something around, what were you saying, 60%?
62.
62% of the actual rated output of this. So well below any kind of nominal tolerance you'd be expecting. So we've taken some time to crack this open, and this is what you'd find inside. So you can see it's a bunch of plates. They're quite thick, and we can look at some of the very high-tech cold soldering technique here. It's just very quickly done by hand. You can see there's an enormous amount of solder here on these joints. The leads are still clipped quite long. They're not clipped flush or anything like that, so they're quite rough and sharp. And if we wiggle this a bit, we can pull this out all the way. And there is a very small little device tucked up in here that's soldered between the ground and the neutral. So I don't know what it's doing there, but this I think it's a fuse on the transformer itself, and if it is, you see this could be on either side of the circuit, and it may or may not actually work. So it might not prevent damage. It'll break the circuit eventually, but it might not break it in time. Here's our rectifier bridge. We've got a bunch of diodes here that are, just very simple, rectify AC to DC, and a single 1000 microfarad, so 1 millifarad capacitor here that's for filtering out the gaps in there. So that's going to be very bad at doing that. We're going to have some fill, but we're going to have a lot of ripple on the DC line, which is not good for our electronics.